Good morning, good afternoon, good evening, wherever you are in the world. My name is Alin Vergatu from Juggernaut Technologies, and I want to thank you for choosing to spend the next 45 minutes with us. As part of this magical show, we will take a tree and we will shrink it. Working for Juggernaut Technologies, the Canadian VAR, is a dream job for a puzzle solver, a problem solver. It has given me access to companies from any industries you can think of. I partner with their engineers, their designers, and I learn how their mind works in modeling, in designing their unbelievable products. And then we sit down, we analyze the methodology that they used, any challenges, any bottlenecks, and find better solutions to improve their productivity. In this process, I'm learning a lot, and I'm always very happy to give back to the SOLIDWORKS community, as you can see on this page. The spark, the inspiration for this presentation came from one of these interactions. And as you can see, Juggernaut has over 5,500 customers, so it's easy to get inspiration. Our customers are privileged. They have extended support hours. As you can imagine, early in the morning there is somebody on the East Coast, and late in the evening we have somebody in Vancouver who is qualified to help them. Before I tell you a bit more about the customer who inspired this presentation, I'm sure you are eager to know what we're going to cover. So instead of an agenda, I'm just going to have a mission statement. We're going to spend most of the time in SOLIDWORKS, not in PowerPoint. I want you to imagine that I'm going to use SOLIDWORKS as an apprentice, as a human being. I have a task in front of me. I have to create a pretty complex part with a lot of repetitive steps. I'm doing this over and over and over and over. Might as well teach SOLIDWORKS how to do it, and then just sit back, relax, and see the job being done. One thing about the tool that I'm going to use, which is the variable pattern, it's a unique tool in SOLIDWORKS. It's almost like running DriveWorks Lite inside SOLIDWORKS. It's the only pattern that accepts as input, as seeds, planes, axes, sketches, reference points. I hope in the future it might accept a few other entities like coordinate systems. That would be really interesting. And you'll see how much time we can save, not only in creating the part, but also later on in modifying the part. Many thanks to David Coiter from Earthscape for providing the inspiration for this presentation. Earthscape is one of my favorite companies because what they build, it's original. They build these playgrounds, which I imagine are like wonderlands for children. And they use only natural material. So a lot of wood, but also these nets made out of rope. And one of the challenges that you will face when you design a rope like this is trying to get a pretty accurate shape about how the final product is going to look like. So let's take a look at this example. What looks like a simple part is actually quite complicated, considering that all these ropes are following the natural shape of a surface. It's very hard to program something like that. That is why in the model on the left, each member of the rope has its own sketch and has its own sweep feature. So the question would be, how can we program this with only two patterns? Let's start by focusing on the model on the left, the one that has lots of sketches, lots of features. And actually, to reveal all the sketches, I'm going to take advantage of the flat tree view. So I hope you guys know, if you go to the tree display, you can use the option show flat tree view. That will free the sketches that are being used in features. So you can see the sweep 1 is using this sketch, sweep 2 is using that sketch. It allows you to see even better the complexity of what we're trying to achieve here. And just as a bonus, I'm going to write down a shortcut. So Control plus T. That will allow you to turn on and off this flat tree view mode. So I'm going to press Control T right now. You can see how everything goes back to the classic tree display. Control T, flat tree view. Let's analyze what's going on here. I'm going to scroll back to this moment in time where I simply have a simple boundary feature created by 4 sketch entities. One of them is this orientation sketch, and I use it just to increase the complexity and also to test the robustness of the model. So for example, if I want to make this smaller, I can simply change that dimension. If I want to change an angle, I can simply do that. And we'll take advantage of all these tools to test the robustness of the model at the end. Let me just undo a couple of times these changes of dimensions. And let's take a moment to explain the mysterious presence of a surface body in our model. Why do we need surfaces? Why do we need surface modeling techniques? We'll take advantage of the fact that any face in SOLIDWORKS, regardless if it belongs to a surface body or a solid body, works similar to a piece of fabric. If you're looking at my shirt, is made out of threads going in 2 different directions. Similar in SOLIDWORKS, any point, let me turn off Instant 3D. If I click on a face, you can see the representation of my click. Pretty much I selected a point somewhere arbitrarily on the face. Well, there is a tool called face curves, which reveals these threads. And instead of using a mesh, I'm simply going to use a position. And you can see that right now when I'm moving my mouse on the face, there is a pair of curves that can be revealed. Moreover, I can choose to keep only the vertical curve. Let me do that by deselecting the blue one. And the other interesting thing, I can specify its position not only by percentage, like you see here, but also by tying it to an existing point. Reference point, end of a line, sketch point, I can do that. And the idea is to place these curves in the correct locations. Allow me to accept this the creation of this curve. Notice SOLIDWORKS actually created a 3D sketch and it placed this curve here. And then I'm going to use the sweep feature, take advantage of the fact that I don't really need a profile sketch if the profile is going to be circular. Let's say 50mm diameter. And you can see right now the solid body was created. Of course, you will ask, why don't you create all the sketch entities defining the path for all the sweeps? And actually I can do that. Allow me to delete this swept feature. And let's run again the face curves to create all the curves that we need. Just one extra tip. If you start the face curve command without being already inside the sketch and use the mesh option, SOLIDWORKS will create individual sketches for each and every one of the curves. If you would like all of this to be grouped inside one sketch, let's try a different approach. I'm going to start a 3D sketch first, and then I'm going to access the face curves. By doing that, all the curves are going to be part of the same sketch. Can I use this for sweeps? Well, of course I can. Allow me just to change the color of this 3D sketch to maybe orange, so it's going to stand out. And maybe even hide the boundary feature. I just press tab, I move my mouse over the face, I press the tab key, tab hides the entity that the mouse is hovering over. So let's attempt to run the swept feature. So I want a circular profile of 50mm. Now when I select one line, or sorry, one curve, which belongs to the same sketch as the others, the selection manager starts automatically, so I can actually select it. Right, so you can see that is my sweep feature. The problem with a sweep, it doesn't accept multiple entries. So if I would say, you know what, I would like to have also this guy as a separate one and this one as a separate one to create multiple bodies, these junk bodies, I cannot do that. So that's not going to work. Even if I take the time to do this one at a time, it will still create a problem if I try to modify it. So let's go to the end of this feature manager and see how robust this model is. So this is what happened. Allow me to show again the boundary surface. So Shift Tab to bring it back. There were several points described as part of a sketch. Face curves were painstakingly tied to each and every one of those points. So just to edit one of these sketches, you can see that when I select this spline, which was created with the face curve command, it actually has a relation called face curve by point. So it's tied to a point that belongs to that previous sketch. And the reason that sketch was created is because it has dimensions. Could have been done different ways. You could have used a segment command to take this curve and apply points that are equally spaced. So there are different ways to achieve that. In the end, though, we needed to create all these sketch entities, all these face curves individual, and again maybe try to apply some color to them so you can see them a little bit better. So that's in one direction. And then we did the same thing for the second direction. First of all, we had a sketch with points defining those positions, and then created those sketch again. The reason for doing all this work is because we wanted to control the position of each and every one of those face curves. So you can see right now, if I make this visible, the two different directions. And then a frame was created using just the edges of the surface. So I hope you guys know that you can do that with sweeps. You can use again the selection manager. You don't need to draw lines. You don't need to draw sketch entities. You simply select edges and you can sweep along the edges. And then all the features were created like that. So apparently the job was done. We just deleted at the end the surface body. Now let's see how robust this is. As I mentioned earlier, I have an orientation sketch. Allow me to turn on instant 3D, and that's gonna change the major surface. If I make this longer, as expected, there are no new members added. Theoretically, I need to add extra points, another face curves, another point, another face curve. What would work really well for me is to be able to build each and every one of these members as instances of a pattern. Let's imagine how we're going to do that. Let's roll back right to the beginning. This is the surface. Now imagine that I'm going to have a point in a sketch somewhere. So right now, let's create a 3D sketch. And I'm going to place a point right here. That's going to have its own dimension. So this is what's going to control the location of this. Let's say 500 millimeter. And then I'm going to create a face curve going through that specific point. So if I select the face and then I select the point, automatically it's going to default to one constrained face curve, and I'm going to deselect the one in the opposite direction. And then I create my sweep, right? So far so good. That's exactly how the first one will work. 50 millimeter diameter. Next, I want the pattern to vary this dimension. So for the next instance, I want to be able to type here, let's say 1000. That's going to move the point, which will move my curve, and then go back and index this to 1500. And you can see how this would move, right? So theoretically, I want each instance to be driven by the location of the point. Well, let's find out how we can do that with a pattern. Let's reload this file, and we're gonna leave it the way it was originally. And let's move on to the second file, the one that contains fewer features, much fewer features than the original. Now let's see how this works. The feature manager really can be separated into two areas. The first one is very similar to what we had before in the previous parts. The second part, these two features, which are variable patterns, are really the magic that make things possible. I'm going to share with you also some limitations and the workarounds that we discover to bypass those limitations. Remember that for this job, we have SOLIDWORKS as our apprentice. The only thing we need to do is to define the position of the first vertical member and the first horizontal member. So we have dimensions for that, dimension 1, and dimension 2. And then we're going to say, Mr. SolidWorks, I want you to put another point here to define the new position. I'm going to tell you what dimension to use, and then another point, and then another point. Through each of those points, please add a face curve on the surface, and then use that for a sweep. This is exactly what a variable pattern can do. If you remember, we said that this is the only pattern that can actually pattern internally reference geometry, including sketches, axes, planes. And notice also sketches as 2D sketches and 3D sketches. So let's try to do this from the beginning, and we will find also some of the limitations and the workarounds, as I promised. Let's start by attempting to create the first path for the first sweep, the first vertical sweep. For that, I'm going to create a 3D sketch. What I need to define first is the position of that. I'm going to try to use a sketch point. I'm going to place it on this curve, and let's use a dimension from the left of 500 millimeter. Always a good idea to name the dimensions that are going to be used in patterns. So let's name this VER from vertical, because this is going to define the positions of the vertical members. I'm even going to attempt to apply a face curve in the same sketch as this point. So I'm going to select the face. Now I'm going to attempt to select the point, and notice I can't. Even if I try to go here and say I want the curve to go through a certain position, and I want that to be just the pink one, I cannot select that sketch point. That's a limitation. So because of that, I'm going to have to leave this in its own sketch. Okay, so let's call this vertical position. Always name sketches, name dimensions that are going to be used in patterns. Next, let's create another 3D sketch and now draw a face curve. So it's going to be based on this face, and notice now I can select the point. I want to keep only the pink one. So this is going to be a spline that's going to be following the natural direction defined by this face, and is going to go through that point. And I'm going to call this first vertical sketch. Okay. Now let's use it to create the first sweep. We already know that's possible. I'm going to use it only as a path, 50 millimeter diameter, and I created it. So far, so good. What about using this into a variable pattern? And you're going to discover the first limitation. I cannot select this sweep. And if I attempt to select it to be patterned, you're going to find a warning saying seed features do not merge with the workpiece, which means that this feature doesn't merge with an existing body. So I need an existing body. That's a major limitation. So let me scroll back before I created this geometry, and let's create the first solid body. I'm going to use again a circular profile of 50 millimeter. Let's use the selection manager for a close profile, and I'm going to select one of the edges. And as you can see, it works fine. Right, so that's the first feature. I have a solid body created. Now the second one can be merged to this one. So I'm going to use the option to merge the geometry. So first takeaway, variable patterns cannot live on their own. It cannot create individual bodies. They have to add geometry or remove geometry from existing bodies. Next, let's run the variable pattern. So variable pattern, let's see if I can select the sweep. Looks like I can. But notice I don't have the dimension for defining the position. So because of that, I need to pattern also this sketch. And now I can see the dimension. Now, let's define the new instances. So this is the seed. For instances, I'm going to select the Create Pattern Table button. And you can see I'm getting this dialog. The cool thing about this, I can select dimensions. So for example, I can select this dimension in order to vary it for next instances. Over here, I can press this button to add another row. And maybe I want this to be 1000 millimeter from the first one. Let's do an update preview and see how it works. So you see what SOLIDWORKS did? It actually created this sketch again with this dimension set as 1000 millimeter, and then created a sweep that is tied to that position. Pretty interesting. Let's take a look at other pieces of functionality over here. I can specify how many extra rows I want to add. Let's say another 5, and then I press this button. Similar to Excel, I can actually select these 2 rows and then drag this down, and notice how SOLIDWORKS indexes everything with the difference between these 2. So let's update the preview, see how this works. Looks pretty good. I think I have space for maybe 2 more, but let's see what happens if I place one that is in a position that's impossible, right? Maybe outside of the original solid body. I cannot merge it to that original solid body. So allow me to add one extra instance, and let's type here a big value, something like 7,000 millimeters. So the distance from the original point to the next sketch is going to be really far away. So if I click OK right now, and I click OK, SOLIDWORKS is going to attempt to do it, but in the end it will fail. Let's see how it will report the failure. Let's take a look at the result. The variable pattern was created, 6 extra instances were added in addition to the seed. I have here 7 instances listed. So 1, 2, 3, 4, 5, 6. Where is 7? It's somewhere in space and nothing was created. But I did not get an error. If I did this feature, this should be actually listed here. So right now I'm gonna say that is probably a bug. The good news is that you can delete this extra instance without having to go and edit the table again. By deleting that, you pretty much remove the row from the table. Now if I go in here and edit the feature and edit the pattern table, you can see the 10th one was removed. A few other pieces of functionality that I really love about this variable pattern. First of all, I like that instances are listed in the tree. They are selectable. Not only you can delete them, but you can suppress them if you want. Suppression is better than deletion, right? Because I can always bring this back. In a way, each instance, it's a meta feature, similar to maybe a library feature that combines multiple features. Remember here I have a sketch, and then I have a feature that has also its own sketch. So in a way, I'm patterning 3 entities in the tree under one of these. The other thing I like is that when I select a feature, I'm getting its dimension. So I can edit this dimension if I want on its own, let's say 2200, and you can see how this entity has moved. Similar to having all those sketches in the tree, you go there, edit the sketch, edit the dimension in the sketch, update, the feature moves. Let's put it back where it was. So double click on it, find the dimension, double click on it, go to 2000, and you have it back in its original position. Let's add new instances a little bit different than before. So I'm gonna go to edit the pattern table, but this time, let's take advantage of the power of Excel. I can export this table to Excel. Let me just save the result and let's take a look at it. Notice that the Excel spreadsheet has exactly these 3 columns. Instances, instances to skip 0 or 1, and the dimensions that I'm controlling if I have here multiple dimensions. So you know what? Let's add 2 more rows. So I'm gonna add this, 7 and 8. I'm gonna get the 0 and select these 2, drag it down. Everything gets indexed. Let's save. And let's return to SOLIDWORKS. Now, there is no direct link between the table and SOLIDWORKS, but I can import from Excel. So let's browse to that file and select import. Select the file, open, and as you can see, 2 extra rows have been added. Let's click OK and OK again. And you can see I was able to add information very fast. This is very helpful if you work with very, very complex parts. Now, let's reload this part. I'm going to do the same thing for the opposite direction. So let's see how robust this approach is compared to the previous one. First of all, it's very easy to create, very easy to generate extra feature, even if I have tens or hundreds of them. It might still take a long time to rebuild, but the generation, the work, the manual work that you have to do is low. Let's change the position of the first seed. So let's type here 300 millimeter. Remember, each and every one of the other instances are like independent features. They don't really care if I change this position. They have their own dimension. So for example, if I go to this one, notice it still maintains whatever was in the table. So that's something to remember. If you need to change something, you either edit a pattern or edit the Excel table and import it again, or you go and manually change the position for each and every one of them. So for example, this one should be 600. That doesn't seem that easy, right? Seems like a lot of work. Well, it's so much easier than having to go and edit sketches, add new points, add new lines, add new face curves. Here, if I want to change this, I establish the pitch between those two, the spacing. I simply select the first two, drag them again, and take a look at the preview. Just added enough. I want to add a few more. Well, I can type here the value, let's say another 5. I'm adding 5 extra. Let's select the last two, drag the bottom right corner, and update the preview. Okay, looks like I have space probably for another one or two. Same thing, deselect, add one, drag this down, update the preview. Looks good. Maybe one more. Update the preview. That was fast, right? Now imagine I need to remove instances. Same thing. Either delete the instances or simply suppress them. So one strategy is to overbuild it. Put lots of instances, have them suppressed, and unsuppress them as the whole part grows. Let's do one more thing. See how robust this is. So I'm gonna go and change some dimensions here. I'm gonna try to make this bigger. Let's go to 7,000. As expected, they're gonna maintain the original distance from that edge, but now we know how easy it is to add extra members. So let's go over here and edit a table, or edit the Excel spreadsheet that I had before. Let's always take a look at the preview. I really like this, right? I don't have to get out of here and try again. So let's add 6 more. It's just a feeling that 6 might be the right value. Update the preview, looks good, and okay. So much faster. Unfortunately, I cannot really use equations or anything else from this point of view to increase or decrease the number of instances. So for that, you're still gonna have to rely probably on the Excel table. That is the fastest way possible. Okay, last couple of tests. What about if I make this taller? So I'm changing really the underlining surface and see how this behaves. What you saw there is pretty much the same thing, right? Over here, I have now space for adding other members. Okay, let's change the angle. So I'm changing this angle, okay? And the last change, let's shrink this down a bit more. See how it goes. Works fine. And I think we might have space for an extreme change. It still works. I'm actually pleasantly surprised to see this part behaving so well. Let's return to the PowerPoint slide and take a look at some takeaways. First of all, best practices. We cannot have multiple bodies generated by the variable pattern. So that's the first thing you have to make sure. Second, name dimensions. It's so much easier to see on those tables names for your dimensions, things that make sense. Name the features that you're going to pattern. So if you have a sketch, a plane, an axis that's going to be referenced by your instances, might as well name them properly. Now, this is an interesting one. You're going to find sometimes that you cannot really select those dimensions to add them to the table. Well, if that happens, make sure that the annotation view containing them are visible. And what I mean by that, I mean exactly this, that annotation views that might contain those are set on show. So sometimes you cannot select specific dimensions, just make sure that these are set on show. Take advantage of the power of Excel. And now let's think about ways to enhance this amazing functionality. We can make it much, much better. What about adding multi-body support? So for example, I can have just one sweep here, and I use this to pattern individual sweeps, creating various bodies. Why not? Why I cannot pattern surface features, right? So if I'm trying to select a surface feature, it's not going to be accepted. Wouldn't be a good idea to have an automatic link to the Excel table? That would save us a ton of time. And also, one thing that I would really love is to be able to see here all those sketches, all those planes, all those axes that are used as reference for patterning. Would be nice to make them visible and actually to be able to use them for other features. Imagine a way to pattern planes this way, very precise way to pattern planes. That's super useful. Another limitation, cannot be used as an input for pattern-driven patterns at the assembly level. And I'm going to leave this slide on for a bit in case you want to vote on this enhancement request. So you vote on them, the chances of somebody started working on fixing or adding this functionality are going to increase quite a bit. In the end, I just want to say thank you very much. And I believe we have now a few minutes for question and answers. I have lots of other examples. Unfortunately, we don't have the time to cover all of them. And now I'm listening to your questions.